Welcome to this introduction video for the Principles of Electrical Science. This unit is aimed at covering for those learners that are studying the Diploma in Electrical Installation. That's City and Guilds 2365, which is Unit 202, and EL 6724, which is Unit ELEC2/08, both at Level 2. The aim of this unit is to enable the candidate who is studying it to know the basic principles of electrical science. The knowledge that's learned provides the foundation for electrical installation, which can be applied when designing wiring systems for clients and when inspecting and testing electrical installations. To successfully achieve this unit, the learner will be assessed by an on-screen multiple choice assessment. The unit contains 6 learning outcomes. Let's firstly look at learning outcome number 1. So learning outcome number 1 is all about understanding mathematical principles which are appropriate to electrical installations, to maintenance and design work. For learning outcome number 1, the assessment criteria is simply to identify and apply appropriate mathematical principles which are relevant to electrical work tasks. To essentially have an understanding of what mathematical principles you need to complete electrical work tasks. In order to do this, there's a range of mathematical principles that you need to be able to understand and apply, which include fractions and percentages, algebra, indices, transposition, triangles and trigonometry, and statistics. As we move on to learning outcome number 2, this looks at the learner having the understanding of standard units of measurement used in electrical installation, maintenance and design work, to be able to identify those that would be used generally within the electrical industry. For learning outcome number 2, there are 3 specific assessment criteria. Number 1, identify and use internationally recognised based and derived SI units of measurement. So the learner needs to be able to identify correctly the types of SI units that are going to be used and how to use them. Assessment criteria number 2 is the ability to identify and determine values of base and derived SI units which apply specifically to electrical quantities. And the third is to identify appropriate electrical instruments for the measurement of different electrical quantities. So the ability to understand what is needed equipment-wise to be able to measure the appropriate SI values. For this particular outcome, there's a range of SI units of measurement that you need to understand, which includes length, area, volume, mass, density, time, temperature and velocity. In addition to that, we have electrical quantities that you need to understand the SI units, which include resistance, resistivity, power, frequency, current, voltage, energy, impedance, inductance and inductive reactance, capacitance and capacitive reactance, and power factor. Finally, you need to understand how to measure specific electrical quantities, which include resistance, power, current, voltage, and energy. Outcome number 3 looks at understanding the basic mechanics and the relationship between force, work, energy, and power. The learner needs to understand how they all interlink together. For the assessment criteria for this particular learning outcome, you need to be able to firstly specify what is meant by mass and weight. Secondly, explain the principles of basic mechanics as they apply to levers, gears and pulleys. Thirdly, describe the main principles of the following and their interrelationships, which are force, work, energy, power and efficiency. And finally, be able to calculate the values of mechanical energy, power and efficiency. The range for this outcome looks at the learner having an understanding of levers at Class 1, Class 2 and Class 3. For learning outcome number 4, the learner needs to understand the relationship between resistance, resistivity, voltage, current and power. This particular learning outcome has 8 assessment criteria. Firstly, you need to understand how to describe the basic principles of electron theory. Then be able to identify and distinguish between materials which are good conductors and those that are good insulators. You need to be able to describe what is meant by resistance and resistivity in relation to electrical circuits. And the 4th assessment criteria is being able to explain the relationship between current, voltage and resistance in parallel and series DC circuits. Assessment criteria number 5, you need to be able to calculate the values of current, voltage and resistance in parallel and series DC circuits. And 6, calculate values of power in parallel and series DC circuits. 7, state what is meant by the term voltage drop in relation to electrical circuits. And finally, 8, describe the chemical and thermal effects of electric currents. For this particular learning outcome, there is no range. Learning outcome number 5 looks at being able to understand the fundamental principles which underpin the relationship between magnetism and electricity and how they all link together. There are 5 assessment criteria for this particular learning outcome. Firstly, describe the effects of magnetism in terms of attraction and repulsion. Secondly, state the difference between magnetic flux and flux density. Thirdly, describe the magnetic effects of electric currents in terms of A. Production of a magnetic field, B. Force in a current carrying conductor in a magnetic field, C. Electromagnetism, and D. Electromotive force. 4 is describe the basic principles of generating an AC supply in terms of A. A single loop generator, B. A sine wave, C. Frequency, D. EMF, E. Magnetic flux, and number 5, identify the characteristics of sine waves. The range for this outcome all revolves around the characteristics of a sine wave, which include root mean square, RMS value, average value, peak to peak value, periodic time, frequency and amplitude. Learning outcome number 6 looks at understanding the types, applications and limitations of electronic components in electrotechnical systems and equipment, and this is the final learning outcome for this unit. There are 2 assessment criteria in this final learning outcome, and the first one is describe the function and application of electronic components that are used in electrical systems. So the learner needs an understanding of how components are used and where they're used within electrical systems. And number 2, state the basic operating principles of electronic components and devices. So in other words, understand how they work. The range for this outcome firstly includes electrical systems such as security alarms, telephones, dimmer switches, heating and boiler controls, motor control and wireless control systems. The range continues with electronic components and devices, which include capacitors, resistors, rectifiers, diodes, Zener, LED, photo, thermistors, diacs, triacs, transistors, thyristors and inverters. The playlists and videos that follow have been put together to help you in your understanding for revising for your exam at the end of this particular unit. Thank you for joining us, and remember, please put your comments on this particular video in relation to things you'd like to see on, comments, changes, etc. Thanks for joining us. My name's Glenn. Take care. Bye.